channel is all about teaching parents how to own their lives and how to own their children's education, because parents are children's first educators. Well, today I want to introduce my brand new series called Teaching Tips Thursday. Alright, Teaching Tip Thursdays is all about me teaching you how to teach and help your child. That way we are building a community and shaping the future together. I hear parents complaining all the time about new math. And yes, Common Core has changed some things. Math is not the same now that it even was 10 years ago. And it's certainly not the same that it was when you and I learned how to do fractions. So today, I am going to break down everything you need to know about third grade fractions. So if you have a third grader, stick around. This is the video for you. So for our very first Teaching Tip Thursday, I'm going to tell you everything you need to know about third grade fractions. This includes representing fractions, equivalent fractions, and even comparing fractions. Today's video will be broken up into 7 different segments. You will learn understanding partitioning, understanding fractions, equal shares, fractions on a number line, understanding equivalence, benchmark fractions, and even comparing fractions. So let's understand partitioning. If 2 friends were to share one pizza and that pizza was just simply broken into 2 parts, each friend would get one of those parts. But then those 2 parts wouldn't be fair. So they have to be partitioned. And partition simply means divided into equal parts. So right now, are those 2 parts fair? No, because I can visually see that one friend is getting more pizza than the other. So let's try this again. And this time we're going to divide the pizza into 2 equal parts. So now let's get into what is a fraction? A fraction is simply any whole, just like our pizza, broken into parts. So as you see right here, we have one whole and it is broken into 2 parts. Now with wholes, they can be represented any form. So as you see right here, we have 6 triangles. All together, they make up one whole. So the total amount of triangles I have in my image is 6. Now let's look at the part. So how many parts is that whole broken into? Well, I can see that I have 5 triangles shaded in. So my part, or my numerator, is 5. That is the number that is always on top of our fraction bar. The whole, or the total amount, is called our denominator at the bottom of the fraction bar. Fractions can be written various ways: standard form, word form, or even visual models. Let's look at this fraction right here. I can visually see that 5 out of 7 pieces are shaded. So that is a visual representative of 5/7. I also see the standard form, 5/7. And you'll notice when 5/7 is written in word form, TH is added to the end, making it 5/7. So what are equal shares? Well, if there are 9 cookies in a cookie jar and Zena wants to share her cookies with her 2 friends, how many cookies will Zena have to eat? So with equal shares, I'm going to divide up my total amount of cookies equally between these 3 friends. So count with me. 1, 2, 3, 4, 5, 6, 7, 8, 9. So now I am out of cookies, and each friend has an equal amount of cookies. So now when I want to see how many cookies Zena ate, I look at her shares and count the cookies. Zena ate 3 cookies. But what would happen if I simply changed my question to how many cookies of the cookie jar did Zena have to eat? Now I want you to look at cookies of the cookie jar. That should signify your child that we are now talking about fractions. So when you have a word problem, you want to think, what is my whole? In this case, my whole was the total amount of cookies in the cookie jar. Now, what would be my part are how many cookies Zena had to eat. So I know that there were 9 cookies in the cookie jar, so that must be my whole or my denominator. And I know now that Zena ate 3 cookies, so that is my part or my numerator.
Zena ate 3/9 of the cookie jar.
Alright, so let's do another problem. There are 40 Skittles in a bag. If you can have 1/4 of them, how many will you have? Well, now I actually have to divide a whole into 4 parts. I know this because I see that the whole, which is there's 40 Skittles in a bag, I then now have to look at my part. So if I'm going to have 1/4 of them, I'm only going to look at how many that one part has in them. So in order to get 1/4, I'm going to have to divide that whole into 4 separate parts. So in order to do this, I'm going to first draw 4 circles. And now I'm just going to simply take those 40 Skittles and then evenly distribute them in each circle. So watch. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40. Woo! That was a lot of Skittles. But now that I have distributed all 40 of my Skittles equally, I simply am going to look at how many Skittles I had in one of those circles because I'm only going to have 1/4.
I will have 10 Skittles because 1/4 of 40 is 10.
Now let's look at fractions on a number line. So typically we're used to looking at number lines like this. And on here you see that we have 8 wholes because each number represents one whole. But with fractions, we are going to narrow down on what is going on in between 0 and 1 because fractions typically are within one whole. So let's look at that one whole, and this time I'm going to divide that whole into 8 separate parts. So all together I have one whole. But each part represents 1/8 because each part is 1 out of 8 total parts. And all those 1/8 all put together gives me one whole. And when you're dealing with a fraction, you're going to simply look at a certain amount of parts. So let's take a look. I'm only worried about these 3 parts. So I see that I have 1, 2, 3 parts on my number line, and each one of those parts represents 1/8. So I can actually add them together, and I know that 1/8 plus 1/8 plus 1/8 all together gives me my new fraction. So I can visually see that I have 3 parts, and total I had 8 parts that gave me my whole. So my part would be 3 as my numerator, and my denominator would be 8 because that was my total amount of parts. So denominator 8, numerator 3. Let's understand equivalence. So here you will see 1 flat. And that 1 flat represents 100 ones because each one of those little blocks is 1 1. And because that flat represents one whole, then that means there are 100 ones within my one whole. So 100 becomes my denominator. Well, as you see, that means I also have 10 ones shaded in. So my part or my numerator is 10. So this flat represents 10 hundredths shaded in. But what if I took that same flat and just broke the tens apart? So you see here, I have not changed my value. I have the same image. I just broke it into different parts. Well, now I have 10 rods. So these rods are broken up and I have 10 rods. And within those 10 rods, I have
1 shaded. So 1/10 and 10 hundredths are equivalent fractions.
Equivalent fractions can be kind of tricky, especially to a 3rd grader. So I'm going to make sure that you fully understand this concept. When you are given visual models of fractions, you want to first look at, am I given the same shape of the same size? So here I'm going to give you various squares that are all the same size. That way, no matter how that square is partitioned, you are going to simply look at the shaded amount. If the shaded amount is equal within both shapes, then you know that they are equivalent fractions. So, I'm given now two squares. They are partitioned in halves and fourths, but I see that in both models I have the same amount shaded, so these must be equivalent fractions. Here we go again. I just partitioned it differently, but it's the same amount shaded, so this is another equivalent fraction. And again, I just partitioned the shape differently, but the same amount is shaded, so this is an equivalent fraction. I can continue partitioning this square into different parts, but as long
as my shaded part stays the same, I know that these are equivalent fractions.
Here I see that I have one whole circle shaded in. So this circle represents one whole. The kids are used to this before they get to third grade. They know that that circle is one whole. But what happens when I take that whole and I simply just break it into two parts? I have not changed the value of the amount shaded in. That entire circle is still shaded in. All I did was give you another circle completely shaded in, but I just cut it into halves. So I see that I have two parts shaded of two holes within this circle. So 2 of 2, or 2 halves, is equal or equivalent to one whole. I'm going to take those same 2 halves
and partition them in halves, and I get that 4/4 is equivalent to 2 halves, which is equivalent to one whole.
Let's do that even one more time. Now I have 4 holes because I have 4 circles shaded. I'm only going to break those holes into halves. So now I have 8 total pieces within my circles, right? And I have 8 total pieces shaded in. Visually, I know that those two are equal because I can visually see the 4 total circles are shaded. But now I notice that I have 8 halves actually shaded in. So 4 holes
is equivalent to 8 halves.
So now you see this visual model of 4/8. I have 4 of 8 pieces shaded in. I'm going to give you the same circle of the same size, but this time it's going to be broken up into different pieces, but the same amount will be
shaded. So 1/2 is equivalent to 4/8.
Now let's look at 3/4. 3/4 is equivalent to 6/8 because I gave you the same shape of the same size and the same amount is shaded. So 3/4 is equal or
equivalent to 6/8.
2/3 is equivalent to 6/9 because I have the same shape, size, and the same amount shaded. Let's look at equivalent fractions on a number line. And we're going to do this through benchmark fractions. And benchmark fractions are simply commonly used fractions like halves, fourths, and eighths, and thirds and sixths. So let's look at our number line just like we did earlier. And I'm going to take that one whole and break it into half. And when I do that, I see that I have 1/2 and 2 halves. And I know that 2 halves is the same as 1 whole. So I'm going to put those on my number line. And now I'm going to break those halves into halves. So when I do that, I see that now I've broken up my whole into 4 parts. So I have 4ths. I'm going to mark my 4ths on the number line. Well, now I can visually see that 1/2 and 2/4 fell on the same part of my number line. Well, now let's break those 4ths into half. And when I do that, I see now I have partitioned my whole into 8 parts. So I'm going to mark my 8 parts. And now I notice where my equivalent fractions fall on my number line.
I see 1/4 and 2/8 are equivalent fractions. 1/2, 2/4, and 4/8 are equivalent fractions. 3/4 and 6/8 are equivalent fractions, and so on.
Benchmark fractions are commonly used when dealing with fraction bars because fraction bars are just really easy to get kids to see how those parts fit together to be one whole. Comparing fractions can be really difficult, so I'm going to take this nice and slow so that you understand exactly what's going on. And we're going to start with an equivalent fraction because we already know how those work. So whenever we're comparing fractions, we are going to use the sign and language of greater than, less than, and equal to. And those are the exact signs that we would use in between our fractions. So we see that we have 2 fourths because we have visually 2 parts of 4 total wholes shaded in. We also have 4 eighths. So I can visually see that I have the same shape of the same size and the same amount is shaded. Those will be our key thinking points when we're going through comparing fractions. So since I have the same size and same amount shaded, then these 2 fractions are
equal.
Let's compare these fractions. I notice that I have the same shape and the same size, but the same amount is not shaded, so I am not dealing with equivalent fractions. So now I know that I'm going to have to do some kind of fraction comparison. So now my next question is, are my 2 shapes partitioned into the same amount of pieces? Well, I know this because I see that both shapes are divided into 6 parts. So now I can simply just look at the amount shaded or look at the numerator. The number with the larger numerator or with the most pieces shaded in
is the larger fraction. So 1/6 is less than 3/6.
So once again, I have the same shape, the same size, and those 2 shapes are broken into the same amount of pieces. I can tell this 2 ways. I can look at the denominators and I can see that both denominators are 6. I can also see that both shapes are broken into 6 pieces. So when the numerators are different but the denominators are the same and the shapes are literally broken into the same amount of pieces, I just simply see which fraction is larger by looking at the numerators. While I know that 4 is larger than 3, I can also visually see that the 4/6 has more boxes or more parts shaded in than 3/6. So
3/6 is less than 4/6.
When comparing fractions that do not have the same denominator, I'm going to go through the same amount of thinking. So I have the same shape of the same size. Great. The same amount is not shaded, so I'm not dealing with equivalent fractions. I'm now going to see if they're broken into the same amount of parts. I have fifths and I have eighths, but my numerators are the same. So in both fractions, I'm dealing with 4 pieces or 4 parts of the whole. Well, when the numerators are the same, but the denominators are different, the number with the smallest denominator is actually the biggest. Look, check it out for yourself. In those 2 circles, I can visually see that 4/5 has more of that circle shaded than 4/8. So 4/5 is actually closer to being one whole than 4/8 was. So
4/5 is greater than 4/8.
Let's do that again. So I have the same shape, the same size, but the same amount is not shaded, so I'm not dealing with equivalent fractions. I then look to see if my denominators are the same or if my 2 visual models are broken into the same amount of pieces. Nope, I'm dealing with 6 and 8. So now let me see if the numerators are the same. The numerators are the same. We just learned with our last example that when the numerators are the same, the denominator that is the smallest is actually the bigger fraction because, let's go back to our model, I can see that 2/6 has more of the circle shaded than 2/8, just simply because the pieces are bigger. So
2/6 is greater than 2/8.
Let's look at these fraction bars. I can visually see that all 3 fraction bars, the whole amount is the same. So I'm dealing with equal shapes of equal sizes. So now I can easily compare them. So we have 1/8, 1/5, and 1/4. I noticed that all of my numerators are the same. So in each one of these fractions, although they're partitioned differently, I'm only dealing with one part of my whole. Well, I can visually see that the 1/4 has more of that fraction bar shaded in. So
1/4 is greater than 1/8 and 1/5.
let's do it again. So I have 3 fraction bars. I notice that my numerators are all the same. So in each one of my fraction bar, I have 3 out of 8 parts, 3 out of 6 parts, and 3 out of 4 parts. Well, I can visually see that
3/4 has more of its shape shaded in. So 3/4 is the larger fraction because it also has the lowest denominator. So 3/4 is greater than 3/8 and 3/6.
all right, well, parents, you just learned how to teach your child and how to help your child with understanding partitioning, understanding fractions, equal shares, fractions on a number line, understanding equivalence, benchmark fractions, and now you know
How to compare fractions.
we sure did learn a lot about fractions. So if you learned and now you feel like you are equipped to teach your 3rd grader fractions, then like this video. And if you're not subscribed to Educate Our Youth, please subscribe. Hit that subscription button. It's really important to me, but it's also really important to you. That way you get notified each Sunday and Thursday that I upload a new video. So Thursdays will be about Teaching Tips Thursdays. And this will be a new series on my channel so that I can teach you how to teach and help your child. See you next